Hi everyone, welcome to this data annotation course. I'm your instructor, and today we're diving into the first part of the material. Hope you're ready, let's get started.
This presentation is about Chapter 3 Image Data Annotation. In this chapter, we'll first look at an introduction to image data annotation. Then, we'll explore the key point marking method, the marking box marking method, and the image area labeling method. Finally, we'll have a summary of this chapter, as well as assignments and exercises. The purpose of image data annotation is that just as humans need learning materials when acquiring a new skill, annotated image data provides learning materials for computers. This enables computers to learn the feature information of images and eventually process image data. Image data annotation supplies rich labeled image data for computer vision research, ensuring effective training of algorithm models. The ImageNet project, initiated by Professor Fei-Fei Li at Stanford University in 2007, labeled over 14 million images and held 8 image task challenges. Teams worldwide participated by writing algorithms for sub-tasks like classification, detection, and localization. This project's success shifted the focus from algorithms-centric to data-centric, realizing data's importance in AI. Here is a table showing commonly used open-source datasets. In image data annotation, users have 3 roles. Annotators are responsible for annotating image data. Reviewers check the annotated data, and administrators manage relevant personnel, issue, and collect annotation tasks. The image data annotation process consists of several steps. First is image acquisition, which can be done through methods like present acquisition or network acquisition depending on the project. Next is image pre-processing, where we check images and remove duplicates. Then, in image pre-identification, a program can pre-annotate data, and annotators only need to review the results, improving efficiency. After that, we select a suitable annotation tool for image annotation according to specification requirements. Finally, we output the results in a specific data format based on data needs. When performing annotation tasks, we should choose an appropriate annotation tool based on the annotation object requirements and dataset formats. Here are some commonly used image data annotation tools. Currently, most annotation documents are stored in XML or JSON, and in some cases, in TXT format. The booming image data annotation industry has provided a solid foundation for the development of the computer vision field in the artificial intelligence industry. Different industries have different data annotation requirements. Its main application scenarios include autonomous driving, where labeled datasets train models to judge road conditions, with markings like pedestrian, vehicle, and road identification. In smart medical, it involves marking points, lines, and contours of anatomical or lesion sites, such as marking lung boundary contours on CT tomography data. In intelligent security, data collection and labeling of faces, roads, vehicles, and actions are carried out for applications like urban road monitoring, vehicle and pedestrian flow monitoring, and public safety prevention. Common types of image data annotation include keypoint annotation, rectangular box annotation, image segmentation, 3D box annotation, and attribute annotation. Different annotation methods are selected according to project needs. Keypoint annotation is often used to mark face key points. By marking key points in different directions, we can determine the actions of people in the image. Here is a sample of keypoint annotation. Rectangular box annotation is a simple method for target detection. It is often used to mark people, vehicles, and objects in autonomous driving. Here is a sample of rectangular box annotation. Region annotation involves dividing an image into regions with distinct characteristics and extracting the interesting parts. It includes open area and closed interval annotation. Region annotation needs to meet the conditions of uniformity, where all pixels in the region share similarity in grayscale, texture, or color features, and connectivity, meaning there is a path connecting any 2 points in the region. Compared to rectangular box annotation, it requires more precise annotation, and the edge can be polygonal or flexible. It is often used for road identification in autonomous driving. Here is an annotation example. Attribute labeling, also known as tagging, uses one or more tags to label the attributes of a target object. It usually selects data from established labels in a closed set. We can categorize pictures by scenes, or label targets with attributes like gender, age, full body, or dress. Image tasks, based on the image dataset after annotation, are related to different classification algorithms. Detection uses rectangular boxes, quadrilateral boxes, or keypoints to locate the target object. Identification combines multiple labeling forms, like labeled frame plus keypoint or labeled frame hitting label, to confirm the target object's coding. Classification determines the category of the target object or scene through attribute labeling. Semantic segmentation uses an image region segmentation tool to determine the target class for each pixel. Semantic description and understanding mainly use attribute annotation for higher-level expressions like aesthetic or emotional aspects in the overall image context. The main methods for feature annotation of image data include marking box labeling, using rectangular or quadrilateral boxes to select the target object. Keypoint annotation marks the location of specific parts of the target with one or more keypoints. Area labeling divides the outline of the target object with an open or closed area. Attribute labeling or tagging uses one or more tags to label the target object's attributes.